Americans do not think about how courts keep their doors open. The courts are just there, and most of us take them for granted. If governmental services must be curtailed due to budget constraints, no one ever considers closing down the court system. Partly because state legislatures, like the one in Tennessee, allocate less than 0.5% of the state's budget for the court system. But keeping the courts open in Tennessee, with the budget the court system does receive, takes planning by the Tennessee Supreme Court. The court must allocate resources, and these resources must be wisely allocated based on experience and informed projections. The administrative office of the courts is responsible for gaining that experience, making informed projections, and recommending allocation of resources to the Supreme Court. These recommendations help the courts function effectively based upon detailed data received from those courts. Consolidating this data into useful information is difficult for many reasons, including the overlapping and inconsistent jurisdictional relationships between the courts and the clerks that serve them, and the bifurcated state and local funding of the court system. In making its recommendations to the Supreme Court, the AOC must understand how much work is being performed by each of the courts, and how resources are being consumed by them by grand division, by county, by court type, by judge, by clerk, by case type, and by other variables, and what the costs are per unit of work, as well as the revenues the court system generates. Let us take a journey, and along the way view the data in the form that it exists today, and the form that it will take if we make decisions that will make analysis easier. We may seem to detour from our path, but the seeming detours will assist us in understanding the significance of the end of the journey. We start by looking at courthouse case management systems. Within the courthouses, Tennessee state courts use several different systems from different vendors for managing local court cases. One of them is the Tennessee Court Information System, or TENSYS, a software product developed for the state by Local Government Data Processing Corporation. TENSYS is an OLTP system. OLTP stands for Online Transaction Processing and relies upon relational databases for storage. The heart of a transactional system is detail about specific activities. In the case of TENSYS, the details are about parties, charges, claims, fines, fees, attorneys, and more applying to specific court cases. TENSYS uses Microsoft SQL Server 2005, an industry standard product known primarily for its relational database features and capabilities. Microsoft SQL Server Reporting Services is included with SQL Server 2005 at no additional charge. Reporting Services has the ability to create and deploy attractive reports from relational databases in HTML, PDF, Word, Excel, and other formats. With familiar tools that have similar interfaces across the Microsoft line of products, end users can often create reports in database systems with which they are familiar. But with systems like TENSYS, which has 412 tables and numerous complex relationships among them, SQL Server Reporting Services, and other products like it, are not enough to permit intuitive query design. Almost all reports in this complex system require programmers and database professionals to design the queries that populate the reports as a part of the application, and these reports cannot be designed ad hoc at runtime. Information exists in the systems like TENSYS to answer the AOC's questions about resource use. But there are many problems with using this data for executive analysis, besides the lack of querying tools for these types of queries. Some of them are that data is too detailed for executive analysis, that there are several vendors of courthouse systems that collect the information where the database design uses different structures and terminology and are not easily merged, that different codes are used by personnel in different courthouses to record data, even where they are using systems by the same vendor, and that once the AOC does have this data, it is not unified into a single database where statewide analysis can be done. analysis that would permit drilling down through the statewide data to various variables in a manner that would reveal trends. A different way of thinking about database design is required in order to permit decision makers to view data from all these transactional systems in a meaningful, responsive, interactive way. The need for this type of thinking has resulted in technology called Online Analytical Processing, or OLAP. As we will see, Microsoft SQL Server Analysis Services is all about OLAP, and Analysis Services is a core component of Microsoft SQL Server 2005. SQL Server 2005 is therefore more than just a relational database. It is a comprehensive database platform providing enterprise-class data management with integrated business intelligence tools that go well beyond relational database capabilities. One of Oakwood's 4 service offerings is business intelligence, and Oakwood believes that the business intelligence approach suggested by the remainder of this presentation and strongly supported by SQL Server 2005, offers the most flexibility and insight for the AOC's analysis of court data at an executive level. We will see how SQL Server 2005 helps make all this work, and how Oakwood can create SQL Server 2005 business intelligence solutions for the AOC. By the end of this presentation, we will demonstrate that AOC analysts and executives can intuitively interact with analysis services through Microsoft Excel to use the data they may already have in ways much more helpful than previously envisioned. We have started the journey at the courthouse, and we have seen that analysis services is the destination. Our first stop along the way is to view an intermediate form of relational database called the Star Schema Data Warehouse, which reformats the data from the relational transactional databases before the data is processed by analysis services. Understanding this intermediate step will help decision makers at the AOC understand the type and amount of work that goes into such a project should it be undertaken. We use the term Star Schema Data Warehouse because data warehouse has been used by others, where they are generally referring to large databases or other types of database analysis, and not to the specific querying techniques described here. The Star Schema Data Warehouse takes the data from many transactional systems and copies the data to a common format with a completely different relational database design than a transactional system, containing many Star Schema configurations. Each Star Schema has a central fact table, which represents events or occurrences which have measures that are always numeric. Therefore, they can be counted, summed, or averaged. Measures could include a count of the number of cases filed, the count of dispositions of cases, as in the example in this demonstration, or the fines assessed per case in an analysis of criminal cases. A single fact table can have many measures, so long as they pertain to the same variables or dimensions. If important measures don't share all their dimensions, and many of them will not, we can make other fact tables in the Star Schema data warehouses and relate those facts to their relevant dimensions. An interesting feature of the Star Schema data warehouse is that end users intuitively understand it. They understand that they are looking at some related measures that can be filtered by relevant dimensions. One challenge of designing and constructing a data warehouse is determining, out of all the tables, rows, and columns available, what are the measures which define the relevant facts upon which to base analysis and projection. Another challenge concerns how we address some of the existing problems that were previously identified with existing data. Remember that one of the problems was that data was in databases from different vendors, each with their own schema. In the past, this translation to the common design of the data warehouse was done by writing low-level, database vendor, and database content-specific programs to do all the work. Remember that data was not coded consistently, in that similar items may be coded using different courthouse terminology. The differences may be small and obvious, or large and subtle. There may be misspellings of key terms, or names may be presented differently, for example. All of these issues affect the quality of the data and the effort necessary to transform the data into a Star Schema data warehouse. Performing the tasks associated with moving, correcting, and transforming the data from transactional systems to star schema data warehouses is called extraction, transformation, and loading, or ETL. Assuring data quality is paramount, and developing the ETL part of the project is the time to do it. It cannot be left to testing at the conclusion of the project. In a perfect system, information would flow one way, from the OLTP system to the star schema data warehouse. But developing the ETL process often detects errors and inconsistencies in the initial capture of the data. This may result in recommendations from the ETL developers to the OLTP system users or to OLTP developers to assure that errors of a detected type are not made and are precluded from being made during initial data entry. With tools provided by Microsoft, developers now have the ability to more easily automate the importing and transformation of data from many different systems across the state into star schema data warehouses at the office of the AOC. The part of SQL Server 2005 which assists in the automation of the ETL process is called SQL Server Integration Services, or SSIS. Because these tools take common issues in ETL and have pre-designed components for many of them, ETL developers can focus on the attributes and tasks specific to a particular project and its data, rather than reinventing similar ETL code for each project and for each type or brand of data source. Even when the measures and dimensions are accurately specified, the shortcoming of a star schema data warehouse is that simple queries can only give one piece of data at a time, the intersection of a measure with a single value from each of the dimensions. In order to make comparisons between many values in a useful way, greater querying ability is needed. SQL Server Analysis Services is the next stop in our journey. Analysis Services stores data in yet another format called a cube. The term cube is a convenience, because usually there will be more than 3 dimensions or variables against which we wish to aggregate and analyze the data. For illustration, let's consider a cube that does have only 3 dimensions. It will be a cube that measures the count of dispositions of court cases. Along one axis, we have the dimension of time. Along another, we have county. And across the third, we have judges. To keep the cube simple, we have a subset of the values that these dimensions might take on. The values that a dimension can take on are called members. If we set one member of each dimension to a fixed value, a single measure will result. But the cube is going to let a user view many of these cells at a time, which gives us a broader comparative view of the data. Because the data is pre-aggregated, we will be able to adjust our querying parameters in real time, without having to wait 30 minutes for a report-generating tool to count through all the detail records of a transactional database to populate the cells of the cube. Let's look at a cube through analysis services based on data from several Tensis databases that have been placed in a single star schema data warehouse. This data is not actual data, or is actual data that has been modified during testing. Some of the data is represented as coming from the wrong county to permit demonstration of how data can be allocated across some dimensions and merged across others. Although we speak of analysis services providing cubes, Microsoft has positioned Microsoft Excel as the actual user interface for Microsoft SQL Server Analysis Services. Analysis Services is server-based, like SQL Server, which means that users from many PCs can connect to a single repository of the data, and Excel is used to make that connection. Security is based on Windows logins and can be limited by dimension and measure down to the individual cell level. Connecting to a cube is not difficult, but if it is viewed as being a chore, users can copy an Excel spreadsheet from a network location which already has the configuration information defined. The details of the steps for connecting are not important here, so we note that they can easily be done by rote with little experience. The important area of the spreadsheet for use with analysis services is called a pivot table. There are places on the pivot table for placing measures and placing dimensions. Dimensions can also be placed to filter the entire view of the data. We will place our first measure in the central area of the pivot table. This cube currently has only one measure defined, but if multiple measures existed for this cube, we could display one or more of them at a time, side by side. Here we see the total count of dispositions contained in this cube. Virtually every cube has time as a dimension, so we will place time across the horizontal axis of the pivot table, although we could have placed it on the horizontal axis. This view may show us more years than we currently wish to view, so we can select individual years for viewing. We may then wish to view dispositions by grand division, and then by county within grand division, and then by judge within county. But notice that our pretend data shows some judges disposing of cases in more than one county, which might be the case if judges are ever temporarily assigned to a different county than the county they ordinarily serve. If we wish to see the total for a judge, independent of county or grand division, then we can remove the dimensions that get in the way and view dispositions by judge. Even if judges do not travel between counties, there will be other dimensions that display this behavior of belonging to more than one drill-down hierarchy. Next, we can ask for analysis showing the year-to-year differences in dismissals by count and percentage. The demonstration-only data shows, for example, that Judge Harvey disposed of 7,122 cases in 2003 and 8,616 cases in 2004, an increase of 1,494 cases, or almost 20%. We can also use a dimension to filter the entire display of the cube if we do not want to display all of its values along an axis, to say, show only cases which are dismissals. We can save the configuration of the spreadsheet as a web page, giving all the interactivity of Excel. This feature uses a special ActiveX control that is licensed as a part of Microsoft Office, and users must have licenses to Excel in order to view these web pages. The users must still have a network connection to analysis services. Security is still enforced by the Windows operating system, permitting users to view only those measures and dimensions they are authorized to view. Notice that the web page has a similar appearance to Excel, and that data that was not displayed in Excel at the time the spreadsheet was made is still available because the spreadsheet is connected directly to analysis services. It is possible to save a portion of the analysis services cube to an operating system file, and this is called a local cube. This local cube can also be created using ETL technology. The advantage of a local cube is that it no longer requires a network connection to analysis services for viewing the cube data within Excel. When analysis services is periodically updated with additional facts or events, a batch process can run to slice off relevant portions of a cube or cubes and email them to remote locations that may not otherwise have access through a network to the analysis services server. SQL Server reporting services, mentioned previously in connection with relational databases, can also be used to generate multidimensional reports as web pages, PDF files, or in other formats that are more attractive for publication. Unlike its use with complex relational transactional systems, SQL Server reporting services is usable by end users to generate reports with analysis services, as the issues in its use are similar to those presented by Excel, which end users can easily grasp. The discussion so far in this presentation has focused on data reflecting what has happened, or what is happening now. What we want to be able to do is predict the future in order to make recommendations. While this cannot be done with certainty, there are tools that use tested mathematical models to help make these projections and give them additional credibility. The field of data mining is also a part of business intelligence and is also a part of Microsoft SQL Server 2005. Using these technologies, SQL Server Analysis Services with data mining, the AOC can estimate the future growth of cases statewide, their types, and the counties in which they will be filed. The AOC can project how many judges the court system will need in the next 5 years, as well as whether fees should be adjusted. Will the physical court facilities available support the work to be done, or must they be expanded or built? These are ultimately the kinds of questions we want to answer, and data mining is the means to answer them. What have we discovered so far? First, we know that the computer systems we are most accustomed to are transactional in nature and store their data in relational databases. Users do not typically have much of an understanding of these relational databases, and they view the data through predefined, rigid user interfaces and have the ability only to query in the manner that has been previously configured for them by programmers. If we perform an analysis to discover the key data elements that comprise measures and dimensions of all the relevant databases and database types, we can extract this data, massage it into a common format, and load it into star schema relational data warehouses. While the design of these data warehouses is often understood by end users, this presentation of the data has its limitations as well. If there are derived and calculated measures and dimensions, such as the year-to-year change calculations shown in the Excel demonstration, formulas for these and for calculations specific to the subject matter of the cube must be defined. The data is then processed from the star schema data warehouses and loaded into the analysis services cubes. Users are then ready to use the data through Excel or web pages using Excel-like features. If the AOC wishes to engage Oakwood Systems Group for an analysis services project, these are the steps which we would follow. The AOC and Oakwood would each identify teams of persons to work together on the project. The personnel from the AOC would include a person who is currently responsible for assembling data from all sources to help understand the data that is available and being used, and the questions the AOC is currently asking and answering. There would also be a person from the AOC that is the consumer of this detailed data, who is responsible for assembling the ultimate executive recommendations to the Supreme Court. The AOC team would include a person familiar with the technical IT infrastructure which exists across the state to assure that all potential sources of data are included, to assist in accessing these systems, and to help implement the automation of the continual ETL process, and to assure the success of the deployment of the end analysis services product. The AOC may also choose to provide the project manager. The team assembled by Oakwood would include a project manager, if one is not provided by the AOC, who is ultimately responsible for coordinating all of the work done in a schedule that has everything come together at the appropriate times for project completion. The team would also include a business analyst, data warehouse designer, several ETL developers, and quality assurance testers. One person may have more than one role in the project. After the teams are assembled, the business analyst will inventory all the court case management systems in use by courts across the state. The business analyst will also inventory the data systems used by the courts that do not directly relate to case management, but which have potential shared dimensions with court case data. Next, the business analyst will analyze these databases to propose candidate measures and dimensions, working with the AOC analyst to define precisely those items which are most relevant to understanding the court system from the standpoint of projecting future use of the courts in Tennessee. The ultimate responsibility for approving the measures and dimensions to be used falls with the executive of the AOC that will be using the information to make the actual recommendations to the Supreme Court. The data warehouse designer will then design the star schema data warehouses. Using ETL developers, Oakwood will automate the extraction, transformation, and loading of data from these transactional systems into star schema data warehouses. There will probably be several ETL developers working in parallel on the processes that will ultimately result in the parallel processing of data from different sources and loading of the data into the data warehouse database. ETL is the biggest and most complex part of the project, and the place where the project manager's skills will be most visible and valuable. The data warehouse designer will assure that the quality of the data from these processes is good. ETL developers will then automate the transfer of the data from data warehousing systems to analysis services multi-dimensional databases, as well as the processing that aggregates the data in advance of its use. The cube data will then be deployed to servers where they will be accessible by authorized end users. Quality assurance personnel assure the correctness of the end product of the entire analysis services project. At this point, Oakwood will be able to make a proposal for defining data mining models to permit mathematical projections of future utilization of resources, and to discover relationships and trends that are not obvious from visual inspection of cube data. Oakwood Systems Group has been in business 25 years and is a Microsoft Gold certified partner. We would be pleased to assist the AOC in implementing business intelligence solutions. We are certain that these solutions will be beneficial to the operation of the courts of the state of Tennessee, and we are confident in our ability to deliver them.